In this video we're going to look at the reactions of the halide ions. These reactions fall into two main categories. The first is the reaction with acidified silver nitrate. This is used as a diagnostic test to tell us which of the halide ions we have present, and secondly as reducing agents, particularly in the reaction with sulfuric acid. Okay, so first of all, the reactions with acidified silver nitrate. This is very useful if you've been given either a set of white solids or a set of solutions that you know has got a halide ion present, but you do not know what the identity of that halide is. So the procedure that you would follow is this. You would take your unknown halide and dissolve it in water, if it's not already dissolved in water. Then you would add a few drops of nitric acid to remove any carbonate or hydroxide ions. The reason for this is that they would also produce a white precipitate upon the addition of silver nitrate and would give you a false result. After a few drops of the nitric acid, then you add in your silver nitrate solution. The silver ions present in silver nitrate react with the halide ions, forming a silver halide precipitate. Now, precipitate is a solid that is formed when you mix two solutions together. The colour of the precipitate will tell us which of the halides we have present, and we'll go through that in a moment. However, sometimes looking at the colour alone can be very difficult to unambiguously decide which of the halides it is, and so then we would add a few drops of ammonia solutions to say definitively which of the halides we had formed, which we had started with. Okay, so here's our little results table. This results table tells us which of the halides we've got, the ionic equations for the chemistry that's going on, the observation you would make upon the addition of the silver nitrate, and then what you would observe upon the addition of ammonia. So in the first one, if you have chloride ions present, so you've got a solution of potassium bromide or magnesium chloride, say, you add in your silver nitrate. The silver ions react with chloride ions and form a solid silver chloride. Okay, it's a precipitate, so it's the solid has been formed. The colour of that precipitate is white, and this will dissolve completely in dilute ammonia solution, the silver chloride precipitate. If you've got bromide ions present, the bromide ions will react with silver ions to form solid silver bromide. We observe a cream coloured precipitate, and this precipitate is not soluble in dilute ammonia, but it will dissolve in concentrated ammonia. Iodide ions, a little more easier to spot. The silver ions plus the iodide ions will give you solid silver iodide. This is a yellow precipitate. It doesn't matter how much concentrated ammonia you throw at this, it will not dissolve. If you have been asked to write an ionic equation, it's important to use the state symbols to show that you understand that you are mixing two solutions together and you're forming a precipitate which is a solid. Now, a favourite question of the examiners also around this is the reaction of fluoride ions. Okay. This test will not work for identifying fluoride ions in, say, like sodium fluoride, potassium fluoride, because the silver fluoride formed is water soluble, so you do not see any precipitate at all. Okay. So, and here we've got a nice little picture. So each of the potassium halides with silver nitrate, so we've got chloride, bromide and iodide. And again, it's going from white to cream to a yellow colour. Again, it's a very pale yellow, granted. When you add dilute ammonia to each of these, the silver chloride dissolves, the silver bromide does not, the silver iodide does not. When you add conc ammonia to these, again, well, the silver chloride's already dissolved, but the silver bromide dissolves completely now, but the silver iodide still remains. Okay, the next video on halide ions will look at their reaction as reducing agents.